Lesson 6.6, Trigonometric Form of a Complex Number. We're going to start by graphing complex numbers. We've done this before. Complex numbers in the form a plus bi. We graph it by moving horizontally a and vertically b because x-axis is the real axis and the y-axis is their imaginary. So this is a is the real part, the b is the imaginary part. So if I want to graph 2 plus 3i, I go 2 in the real, and then 3, the imaginary, so the point is right there. Or if I want to graph negative 3 minus 4i, I go negative 3 and then down 4. So it would be that point right there. For a complex number, the absolute value, well, for all numbers, the absolute value is defined as the distance from the origin. For a complex number, here's the origin, so it looks like it'd be the length of that line. Well, to find the length of that line is the distance formula. So it's the distance formula. Notice there is no I in our little formula. So find the absolute value of 4 plus I. Well, 4 plus I would be the square root. This is a 4. And this is a 1i, so it would be 1 squared. 4 squared plus 1 squared. So that would be 16 plus 1. So the square root is 17. Notice there was no I in there. It's always adding inside the square root. This distance is always positive. It's always a real number. All right, now let's get to the trigonometric form. On this little diagram here, if we call the absolute value r, then a is r times cosine of the angle. B would be r sine of the angle. And tangent, r would be the square root of a squared plus b squared, so I'm letting that be the absolute value. And tangent of the angle would be b over a. Well, if z is a plus bi, then a is r cosine theta and b is r sine theta. We could factor out the r and we get that, and that is the trigonometric form of a complex number. So you do kind of need to know that, hence it's a different color. The r is called the modulus, theta is called the argument. So let's write this in standard form. It is in trig form. Let's change it to standard form. It's really pretty straightforward. We just do our calculations. So cosine of 2 pi over 3 is negative 1/2. And sine of 2 pi over 3 square root of 3 over 2. So let's just distribute. 8 times negative half would be a negative 4. And the 8 over 2 reduces to a 4, square root of 3, and your I. Well, look at that. It's in standard form. How about going the other way? Let's write the standard form into trig form. Well, we need to find everything, so let's find r first. R was a squared plus b squared, so that would be the square root of negative 2 squared plus negative 2 squared. Don't put the I. So that's the square root of 4 plus 4, which is the square root of 8, which is 2 square root of 2. So r is 2 square root of 2. Tangent of the angle is b over a. So tangent of the angle is negative 2 over negative 2, which is 1. Now remember, on the unit circle, tangent equals 1, 2 places. Right there at pi over 4, and down there at 5 pi over 4. Its tangent's positive in quadrants 1 and 3. So we need to look at our point. Negative 2, negative 2 would be graphed down here. So our angle is 5 pi over 4. So you do have to look and see which quadrant your angle is in. So our answer, Z, is r cosine theta plus I sine theta. So it's 2 square root of 2 cosine of 5 pi over 4 plus I sine of 5 pi over 4. That's all there is for today. Have a good day.